Have you ever pondered why we experience sadness and what role it plays in our lives? It's a question that invites exploration, a journey into the depths of our minds and emotions. The feeling of sadness, often perceived as an unwelcome guest, actually holds a significant place in our existence. But what is the science behind this complex emotion? Why do we feel sad, and what purpose does it serve us? The answer lies deep within our brains, in the realm of neuroscience. The science behind sadness begins with our brain's basic structure and function. Our brain, a marvel of nature, is a complex network of billions of neurons that interact and communicate with each other. This intricate dance of neurons is what allows us to experience a wide spectrum of emotions, including sadness. The brain's limbic system, often referred to as the emotional center of the brain, plays a key role in our experience of sadness. Within this system, two structures, the amygdala and the hippocampus, have been found to be particularly important. The amygdala, a small almond-shaped structure deep within the brain, is primarily responsible for processing our emotional responses, including fear and sadness. When we encounter a sad event, the amygdala springs into action, triggering a cascade of reactions throughout the body. The hippocampus, on the other hand, plays a crucial role in forming memories associated with these emotions. It helps us remember the emotional context of past events, which can then influence our present and future emotional responses. So, if we've experienced sadness in a particular situation before, our hippocampus helps us remember, and we might feel sad when we encounter a similar situation again. But it's not just about the structures in our brain. There's also a chemical side to sadness. Neurotransmitters, the brain's chemical messengers, play a significant role in our feelings of sadness. Two neurotransmitters in particular are noteworthy: serotonin and dopamine. Serotonin, often referred to as the feel-good neurotransmitter, regulates our mood, sleep, and appetite, among other things. When serotonin levels are low, we often feel sad or depressed. Dopamine, known as the reward neurotransmitter, is associated with pleasure and reward. It motivates us to take actions that will lead to reward. However, when we're sad, dopamine levels can drop, making us feel less motivated to seek out pleasurable experiences. So in essence, our brain's intricate wiring and chemical signals shape our experiences of sadness. It's a complex interplay of structure, function, and chemistry that allows us to experience this universal yet deeply personal emotion. It may seem counterintuitive, but sadness isn't all bad. In fact, it serves some important purposes. Let's delve into the silver lining of this seemingly dark cloud. Sadness can act as a conduit for processing complex emotions. It allows us to pause, reflect, and navigate through the labyrinth of our feelings, fostering a deeper understanding of our emotional landscape. Moreover, experiencing sadness can heighten our empathy. When we've walked through the valley of shadows ourselves, we're better equipped to empathize with others in their time of distress. We become more compassionate, understanding, and in tune with the human condition. Interestingly, sadness can also stimulate creativity. It's no coincidence that some of the most profound art, music, and literature have been birthed from periods of melancholy. Sadness can unlock depths of emotion and imagination that fuel creative expression. In these ways, sadness can actually be a catalyst for personal growth and transformation. However, like anything in excess, prolonged or intense sadness can have detrimental effects. Let's delve into the darker side of sadness, where it morphs from a natural human emotion into a chronic state that can lead to more serious conditions like depression and anxiety. When sadness settles in for the long haul, it can transition into depression. Depression is more than just feeling blue. It's a persistent state of sadness, often accompanied by a lack of interest in life, fatigue, and feelings of worthlessness. The World Health Organization estimates that more than 300 million people worldwide suffer from depression, which can be debilitating and, in some cases, life-threatening. Moreover, chronic sadness can also trigger anxiety. Anxiety is a state of constant worry and fear, which is often out of proportion to the situation at hand. It's like a faulty alarm system in your brain, constantly sounding off, making everyday tasks feel like insurmountable challenges. But what's happening in our brains when sadness becomes chronic? Neurologically speaking, prolonged periods of sadness can cause changes in brain structure and function. Certain areas of the brain, like the amygdala and the hippocampus, can become hyperactive. This overactivity can lead to the overproduction of stress hormones, which can damage neurons and inhibit the creation of new ones. In particular, the hippocampus, which is critical for memory and learning, can actually shrink in size. This could potentially explain why people suffering from depression often have difficulty concentrating or remembering things. Furthermore, chronic sadness can disrupt the balance of neurotransmitters, the chemical messengers of our brains. This imbalance can affect our mood, appetite, sleep, and overall sense of well-being. Thus, while some sadness is natural and beneficial, too much can disrupt our mental health and well-being. It's crucial to remember that it's okay to feel sad, but if sadness becomes prolonged or intense, it's important to seek help. After all, understanding the science behind our emotions is the first step in taking control of our mental health. So, what have we learned about the neuroscience of sadness? We've journeyed through the intricate labyrinth of our brains, exploring how different regions and neurotransmitters play a part in the emotions we feel, particularly sadness. We've touched upon the amygdala, the hippocampus, and the prefrontal cortex, each with its unique role in the orchestration of our emotional responses. We've delved into the world of neurotransmitters, those chemical messengers of the brain, serotonin, dopamine, and norepinephrine, each playing a part in our emotional symphony. We've seen how an imbalance can lead us down the path of prolonged sadness or even depression, but we didn't stop there. We've also looked at the brighter side of sadness, haven't we? We've seen how it can serve as a signal, a beacon that helps us identify our needs and wants, how it can bring about empathy, fostering understanding and compassion, and how it can spur us into action to make positive changes in our lives. Yet we mustn't forget the potential harm of excessive sadness, the bad and ugly. Prolonged periods of sadness can lead to detrimental effects on our overall well-being and mental health. It's a delicate balance, one we must strive to maintain. While sadness may be an inevitable part of life, understanding its neuroscience can help us navigate it more effectively. Remember, it's okay to feel sad, but if the sadness persists, it's important to seek help.